In the last video, we learned about determinants. Now we're going to learn about Cramer's rule. So with Cramer's rule, the solution of the system, here's just one equation in x and y and another equation in x and y. The x will be the determinant. It's a ratio of determinants, x and y. So the d with the subscript of x is the determinant c1 b2 minus c2 b1. And the dy is the a1 c2 minus a2 c1. And the d is a1 b2 minus a2 b1. And so I'm not going to memorize this as a formula. What I'm going to do is remember instead, if I create d as the matrix that's the 2 by 2 matrix of coefficients, a1, a2, b1, b2, right there. And then I take determinant d and I replace my x column with the c1, c2. So this is, the x column is just replaced with the equal sign, but otherwise it's the same determinant matrix. And the y is, again, this matrix, but the b's are replaced with c1, c2. So we just form the determinant d and then replace each one with either the c1 or the c2. Let's take a look at an example here. I want to use Cramer's rule to solve this system. So we know that x is dx over d and y is dy over d. We got to form that d and dx. Whoops. So my d is the determinant 3, 2, 2, negative 1. And by the way, notice that when I use the brackets, that's a matrix. When I use just straight lines, that's a determinant. Okay? So here, I would say this is 3 times negative 1 minus 2 times 2. So we get negative 3 minus 4, or negative 7. Now, to get dx, I use the same matrix that I formed right here, but I replace the first column with negative 4, negative 5. And so working that out, I'd go negative 4 times negative 1 minus negative 5 times 2. That's going to be a positive 4 minus negative 10, so 14. All right, now to get the dy, we go back to this original matrix here, but I replace the second column with the negative 4, negative 5. So that's 3 times negative 5 minus 2 times negative 4. So negative 15 minus negative 8 is a negative 7. So my x is this value, which was 14, divided by this value, negative 7, so that's negative 2. And the y is this value, negative 7, divided by this value, negative 7, so that's a positive 1. So my solution is the ordered pair where x is negative 2, y is a positive 1. Plug it in to make sure it works. Negative 6 plus 2 is negative 4. Negative 4 minus 1 is negative 5. That works. Now, we're doing the same process for a 3 by 3. Form the matrix D as being the coefficients of the x in the first column, the coefficients of the y in the second, and the coefficients of the z in the third. Then you're going to replace the first column with the d's. Everything else stays the same to get the dx. Then go back here and replace the middle column with the d's to get the dy. And then go back here and replace the last column with the d's to get the dz. Okay? A little longer process. All right, here, if I look at my d, the determinant would be 3, 5, 0, because there's no z. 2, 0, 7. And then 0, 4, 3. All right, so if we work out that determinant, we'll just span across the first column here. So I'd go positive 3 times 0 minus 28. So 3 times negative 28. Then minus 2 times, cross out its row and column, and I'd have 15 minus 4 times 0. And then plus 0 times anything is 0, so I don't have to worry about the last one. So negative 28 minus 30, so negative 28 times 3 would be negative 84, I think. Minus 30 would be negative 114 for the D. All right, so now my dx, we replace the first column with negative 7 to 8. Okay, and then I'm going to span across the second column because it's got a 0 in it. So I'm going to start with a negative because this is in place 2, 1. So 2 plus 1 is 3, it's odd. So it starts with a negative. All right, 5 times, cross out its row and column, and you have 6 minus 8 times 7 is 56. And then plus the 0, so 0, and then minus again the 4 times, cross out its row and column, negative 7 times negative 7 is negative 49, minus 2 times 0, so just negative 49. So we get negative 56. Man, I didn't realize how much there was in here. Let's pull out the calculator. This will be faster. Let's just keep that, but let's pull out the calculator because I could be making some mistakes here. So this is one that's not too great to do by hand. All right, so matrix A, oops, I want to go in there and edit that to be a 3 by 3, and it goes 3, 5, 0, 2, 0, 7, and then 0, 4, 3. All right, so we're going to quit out of there, and we're going to go determinant is in math, A, and let's check ourselves. Okay, good, we did that one right, negative 114. All right, now let's go edit A. Oops. Edit A, and we're going to replace that first column with negative 7, 2, and then 8. Oh, negative 8. Oh, goodness, I missed writing in a negative, so that would have made our answer different anyway. Good thing we caught this. Okay, negative 7 to negative 8. All right, now let's quit out of there, and then I can just do the same thing again. Determinant A, we get negative 114 again. So this should have been a negative 8. So ignore all this. I did that wrong. So this is negative 114. All right, now dy is going to be the same thing. 3, 2, 0. I'm looking right here. And I'm replacing the second column with negative 7, 2, 8, and then 0, 7, 3. And we're going to work that out on the calculator. And dz, again, I'm going back here. So the first 2 columns stay the same. I'm replacing the third one with negative 7, 2, 8. Negative 8. I missed it again there. Okay, so let's work those out. So we need to edit that matrix again. And let's replace that first column with 3, 2, 0 again. But now we're replacing the second one with -7 to -8. Whoops. -7 to -8. And then go back to the home screen. And let's do the determinant of A, and we get 228 for that one. Okay, so that one's 228. Now let's adjust it again and figure out the last one. So we're going to go edit, and we're going to change that second column back to 504. And we're going to change that third column to -7 to -8. And now let's quit out of there, back to the home screen, and calculate that determinant one more time. We get 0. So 228 and then 0. Okay, so my x is this guy divided by this guy. My y is this guy divided by this guy. And the z is this guy divided by this guy. Okay, that's +1 for the x, -2 for the y, 0 for the z. So that ordered triple solves our system. Let's check it. 3 minus 10 is -7. Yep. 2 plus 0 is 2. Yep. -8 plus 0 is -8, and that is true. All right, so why can't we use Cramer's rule here? Well, we cannot use Cramer's rule if our determinant ends up being a 0 for that d. So let's look at it, right? Because notice that d was in the denominator in all of these. So with d being in the denominator in that expression, I can't solve by d if that's a 0. So working this out, I'd have 2, 3, 4, 6, -9, 12, 1, 2, -3. And now let's go to our calculator and let's work this out. So I'm going to go to second matrix, over here to edit, option A, and let's keep our 3 by 3, but we're going to change the values here. And, oh, actually, it's already done for us there. So we can just use that. I didn't advance far enough, right? We plug in our A, calculate the determinant A, we see it's a 0. That tells us that we can't use Cramer's rule to solve that system. It tells us more than that. It tells us the system is inconsistent.